Afternoon, everybody. Soon as just turned 12, we're just going to let some of our colleagues and audience enter the room, and once we've got a decent number, we will get started. Okay, they're starting. People are starting to come into the webinar as we speak. So I will start. So welcome, everybody. My name is Paul Schaffer. I'm Director of Projects at CIWEM, and this is our Lunch and Learn webinar on being delivered by BeFloodReady, and it's on the technicalities of delivering property flood resilience. So webinar's being recorded, and at some stage within the next month or so, it will be placed onto our CIWEM YouTube channel. And if you visit there, you also see that previous videos from BeFloodReady will also be there. If you experience any technical issues and need any assistance, please use the chat feature, and my colleague Barbara Woods from CIWEM will help with that. We are also really keen to deal with some of your questions, and so we will take questions at the end of the presentations. But please use the Q&A facility as you would do in Zoom, and there's also an opportunity to vote for questions. So it's an interesting time for those working in flood resilience. I'm not sure if you're aware, but in a few weeks' time, on the 13th of October, we have Flood Action Week, and there's a number of activities happening. One of which will be the launch of the Flood Ready report, which is an action plan that's being chaired by Peter Bonfield, looking at ways to mainstream PFR. And Andy, in his presentation, will give a bit of an overview of where we've come to and where we're potentially going to. But what is CIWEM doing in this space at the moment? We're really keen as a professional body to lend our support to both the public who are at risk of flooding and also the professionals that are delivering services and support and guidance to the public, property owners, in terms of dealing with the flood risk. So what we're doing with BeFloodReady community practice is developing a sense of community, hoping to improve the competency and understanding of PFR with a view to improve competence both of the public in terms of the competence of the people that they're employing to deliver PFR, but also the competence of those professionals delivering PFR. And we're also really keen to ensure that there's greater consistency in terms of delivery. The work is underpinned by a website and where we're hosting and signposting a number of resources related to PFR. At the most recent count, there's about 140 or so resources that could be searched in terms of keywords, also in terms of their suitability for the public and professionals. We host events, as we talked about previously, our webinars on a number of topics relating to innovation, delivering PFR, and also the role of engagement and community engagement and working with people along the process. We've got over 15 case studies that signpost and showcase some of the successes of delivering PFR. And we also got links to accredited training and events that we're going. And if you join our website, and there will be a link circulated on how to join, how to visit the website, and how to join the community practice. We can also receive blogs and newsletters. And later in a month, we will be also hosting our specialist register for PFR professionals. This is something that we're progressing to provide that confidence in the delivery. And the idea is that practitioners will have completed the training, would have demonstrated a competency through a report that outlines how their experience aligns with specific standards relating to their role. They will also be referred by a member, and we also review their CV. And we're looking at the moment for 2 specific roles that will be listed on this register. One will be the surveyor, and the other one will be the installer and contractor that is delivering the PFR. We really love you to get involved in the community practice that we're developing. So please do visit the website, sign up for the community practice, but also we'd love to hear from you in terms of case studies, any news items that you would like to share. If you've got any opinions or information or discussions that you'd like to have, we'd really welcome blogs. We're looking for resources that we may have missed, and also if you've got any suggestions for event topics. Community practice is funded by these organisations. We have funding to take us up to the end of this year, and we're looking for funding to move us forward from 26 onwards. So if you are interested in demonstrating some thought leadership, having benefits related to sending your teams and staff onto training, and also want to be able to network with peers, this could be the organisation for you. So I just wanted to say thank you for those organisations, because this webinar wouldn't be possible without them. So this agenda is really looking at the technicalities, and we've got 3 great speakers. We've got Andy Tagg, who's the past chair of BS 85500 on the flood resilient construction. And we've also got Elaine Toogood from the Concrete Centre, who's going to give an overview of the British Standard and what's changed and why it matters. And then recognising the importance and the need to align and ensure that PFR can coexist well with historic buildings. We've got Joanne Williams from Historic England. So, and then we will finally finish with Q&A. So the idea is that we will finish probably at 1. So I will make sure that we keep to time where we can. So without any further ado, I'll pass you over to Andy.
Okay. Okay, so thank you, Paul. So I thought that before Elaine sort of gives the highlights of what's in the new standard, it would be useful to sort of just explain and give a sort of personal history of how we've got to this position. Because actually, it's been 20 years that BS 85500 really started. So I got involved in 2005 with PFR. And what was happening at that point? Well, flood protection products or flood resistant products, they were fairly well established at that point in time. We had a test standard, PAS 1188, that had been agreed in 2003. And as you can see there at HR Wallingford, where I used to work, we had a very large test centre that was set up. And that ran between 2002 and 2006. And back in 2005, we had several products that had been tested, had got type marks, and we had a good industry that was sort of, starting to flourish and make sales to people who'd been flooded. And that's why we started to look at resilience, which at the time was completely separate from resistance. So in 2005, what we call resilience is now what we would call recoverability. So if we go to the next slide, Paul. Oh yeah, and that's just showing that back in 2005, there was also testing of temporary and demountable devices, but in the main, most of the testing was flood barriers, air break. Okay, so the next slide. So back in 2005, DCLG set up a project led by Syria, and Paul Chaffel was, I think, the project manager for that. And it was a research project looking at property resilience. And as you can see there was HR Wallingford, WRC, and the Leeds Metropolitan University. We carried out an extensive literature search. We interviewed experts. WRC looked at the regulatory and legislative background to what would be involved in pushing forward the resilience agenda. And one of the key aspects that I was involved in was actually testing both materials and wall and floor constructions, as you can see there. Because even though there was a lot of common sense around, we couldn't find much hard data. So here's just an example of what we came up with. This is looking at individual elements, so individual blocks and bricks, and we had to come up with what we thought resilience might be. So as you can see there, we looked at water penetration, drying ability, retention of pre-flood dimensions, and we gave a sort of scoring system. So if you go on to the next slide, and the main outcome of that was guidance that was launched in May 2007. It was launched by the minister. I'm still very proud of that document. It is still available. And it was used by some local authorities, but really it didn't get the prominence it should have done, because in June the following month, and then in July 2007, we had the wettest summer on record. And that was so devastating, it led to new legislation with the Flood and Water Management Act. And in a way, it didn't, the guidance didn't really get taken up. Done with that very well. So now we move on to 2009. The PAS 1188 standard for flood products was updated, and we had to build some new test rigs at Wallingford. So this is just illustrating the test rigs at Wallingford. A couple of other organisations also started to offer testing here, and this was the point in time when we started to see flood doors appear. So that was a little marker in the sand. Then in 2014, DCLG approached BSI and said, we'd like you to turn the 2007 guidance into a standard, because I think that would help dissemination. Attention had turned more and more to property flood resilience. And so as you can see there, that's the front cover of the 2015 guidance that was turned into a standard. And I should also note that the government was hoping that would act as a bit of a trailblazer, so that BS 85500 as a trailblazer under that initiative Rethinking Standards in Construction. And that was quite important, because the coalition government at the time was trying to minimise and get rid of a lot of regulation, and so that's where BS would fill the gap. That's just a sort of overview of what was in that standard in 2015. I wouldn't worry about that too much, because what's more relevant is what's going to be in the next one. So shortly after when that first BS came into being, Peter Bonfield from BRE carried out a review of property flood resilience, and Paul just alluded to the fact that 10 years on, he's carried out another review, and so we had the action plan produced in 2016. And if you just go down, Paul, the contents there. So the action plan was framed against 6 sort of headings. With my background, I was obviously very interested in the standards one, but that has been absolutely instrumental in pushing forward the whole of the property resilience agenda. And shortly after the publication, there was the Property Resilience Roundtable set up, and that has been absolutely paramount in pushing the agenda. One of the key outputs and successes from the roundtable, if you just go back, Paul, was actually looking at providing guidance to homeowners, but also the wider industry, on what's needed in terms of installing property resilience. And so this just shows here that it's just the same as any engineering scheme, that you need to carry out surveys, flood hazard building surveys. You need to select what components you're going to install. They need to be installed by competent individuals, and then you need proper sign-off, operation, maintenance, and aftercare. So all of that was captured on the next slide with the Syria Code of Practice that was published in 2019. So that's the Flood Resilience Code of Practice that sets out these 6 stages to capture that engineering process. And I've noted at the bottom that there was very detailed technical guidance that came along in 2021 to support those standards. And the in the latest work that we've done on the new updated standard 85500, we've completely recognised and dovetailed into that code of practice. So you know, we only cover 2 of those steps in the new standard, but we make full recognition that, you know, we are part of that engineering stream. So just to say that in terms of what's in the new standard, we started work in 2021. It was finally published in 2025. I think that reflects not only poor chairing on my part, but also the fact it's had a completely major update. There's been a lot of discussion. It's now 70 pages long. As you'll see from Elaine's presentation, there's a lot of more extensive detailing and drawings in there. And I think one of the key aspects is we've got the improved knowledge and uptake of PFR over the past 10 years, linked to getting very valuable input from the roundtable members, many of who sat on the drafting committee. That included insurers, loss adjusters, construction and rehabilitation. So what you've now got before you that you're going to hear from Elaine now is a much improved standard. And I think that's when I'll hand over to Elaine.
Thank you very much. So yeah, my name's Elaine Tugard. I'm senior. Thank you very much for that intro, Andy. I'm a senior director of concrete at MPA and one of the members of that PFR roundtable that Andy just mentioned. So in this talk, I'm going to, as you said, 70 pages, huge amount of detail, not possible to get through it all in 10 minutes, but I'm going to give an overview of what's really changed in terms of the actual guidance and the approach that's been taken, building on all that knowledge, as Andy said, an experience since the previous report was published in 2015. And I'm also going to highlight what I think is really good and useful about the document. So as I said, it's about improving the resilience of buildings through consistence of resistance and recoverability, and through consideration of materials, construction and detailing. And I think what's important here is that it's relevant to the design and specification of flood resilience of new buildings, extensions, conversions and retrofits, but it's also useful not just for buildings that are in flood zones, but also those that are at risk of surface water flooding. And we're increasingly seeing that as being something that we need to be taking consideration of. So next slide, please. What I would say is that I'm just giving some extracts. All of those extracts in this presentation have been, we've got permission to share them from the BSI, but I just urge you, you're not going to get all the guidance here. You need to download that document itself to look at it, and the link I think has been provided in the chat. So what are the principal changes? Well, as we already heard, it makes reference to that CIWEM code of practice, and is consistent with that was published since the first one. But it also provides a comprehensive list of impacts of floodwater to all common materials and building elements. There's a lot more detailed guidance. It's supported by detailed drawings for both flood resilience, new builds and retrofits. And as Andy said, it really benefits from all that experience and knowledge that's been gained in the subsequent 10 years. And I just want to just press return because I just want to draw attention to a really core updated definition, which if you press return for the next slide, you'll see, and that is that flood resilience is a combination of both resistance and recoverable measures. And that's one of the core fundamental difference from the way that the descriptions were happening 10 years ago. So it's about incorporating building fabric and fixtures to reduce the consequences of floodwater affecting the property. So it's about the resilience as the whole. So what's in the standard? Well, you can see it's 2 halves. The first half, I would say, is very much about general principles, guidance, assessment of understanding, not there about the solutions, but a lot about it's about encouraging understanding of the hazards and how they relate to the design processes. So, and then that moves down through into section 5, where there's a much more of quite a comprehensive list about potential damage, the ingress that might be a result of a flood impact and the hazards, looking at characteristics of floors and walls. And a new part of this guidance is about the MMC. So there's a section in there on the impacts and guidance with regards to using MMC construction. And I think that's an important point to look at. One of the key parts that I picked up from that section is the requirement for manufacturers to be able to demonstrate that this is a flood resilient solution. And of course, that's an important consideration given the potential focus on industrialized construction that's coming through. One of the points that I picked up there is that, you know, SIPs, there's one bit of guidance that says that SIPs need to be swapped out for masonry because of inappropriate to improve the flood resilience. And I think that's an important point to recognise. That section, that bit of guidance comes out in the second section, which is where the real detail is there in terms of providing input into how to design. So initially it talks about design strategies at a more general level, so thinking about site layout, but then it very quickly gets into, in section 7, detailed guidance for new build, and that is through information guidance, but also a series of illustrations on flood resilient solutions that are common wall and floor constructions. Then talks about them for retrofit, and picks out a couple of key and common scenarios, and then looks at how they can be improved from a resilience point of view. And these are detailed drawings, and I'll show you an example of them later on. Then followed by a bit more further guidance on doors and windows, fixtures and fittings, and then finally with workmanship and sustainability. And it's that sustainability bit that is a really important key thing, and something that I particularly like about this new version, because it takes into account sustainability throughout the document in 3 ways, I think would be my summary. So the first one is is underlying all the principles is to do with the principal solution of a lean solution. So guidance to limit unnecessary ripping out of materials and less associated construction waste and resources and carbon associated to it. The second one, which is on your screen now, is is climate change resilience. So the guide recognises and gives guidance on the need to consider climate change resilience as part of the analysis for potential hazards and climate risk. And as I said before, it also incorporates guidance with regards to surface water flooding, which we're increasingly starting to see as an impact of the impacts of well, various different reasons for surface water flooding, but often as a result of climate change. And then critically and really usefully, as my third point with regards to sustainability, is the guidance includes a lot about insulation. There's a section on the impact of building materials that includes a lot of guidance about the type of insulation to use and what you should be looking for within specification. All of the built drawings include insulation, so therefore establishing principles of flood resilience with insulation in place. And that's particularly crucial with regards to retrofit, because of course, if you're going to be doing any major bits of work post a flood event, actually this is a real opportunity to be able to then improve the thermal performance of the property. And the previous guidance, I know from experience, I remember trying to go around the guidance, I was chasing around, where do I put the insulation? Where do I, what type of insulation is needed? And that has been nailed in this, as far as I can see, in this document. And I think it's a really good move forward in terms of the way that the guidance that we're providing. So bringing together very many of those issues that we all need to be thinking about when we're considering sustainability as well as embedding flood resilience. So next slide, please. So I've just shared 2 of the various drawings that are in the guidance documents, and I think this is again a real step forward. All the details shown in the document are junctions between floors and walls, And that's a real improvement, because the junctions are often where many of the issues arise for flooding. It's it's the relationship between the two. A focus on so there's guidance to convey the principles of materials and design selection. It's not just a series of solutions. It's also trying to raise awareness and understanding of why something is done in a certain way. And I think that's really critical for that understanding then for designers and anybody involved within this is able to apply that to their projects. Flood resilience, I think, hopefully, as most people are aware of, is not, it's got to be a whole system approach, a whole building approach. It's not reliant on just one element in isolation or a product in isolation. It's often the junction, sort of the critical areas of consideration. And there's more, the guidance has moved on quite a lot from that simplistic sort of possibly even misleading table that Andy shared earlier on, which just looked about products. You've got to be looking about the whole thing, coordinates it. And what I would say is that all the resilient solutions there that are illustrated are concrete and masonry. Now, why is that? Well, you could then go back and understand that by looking at some of these tables in the section 5, where we've got tables 2 and 3 provide really useful summaries about commonly experienced actions and impacts of flooding on materials. And if you just look at the extract that I've got there, masonry, so why is masonry included as a solution? Well, actually, one of the most common is to do with the mortar. It's not actually the structure of the building, like if it's constructed in masonry, where the impacts of flooding are likely to be impacted. By comparison to the timber frame with the extract there, which is if it's got under prolonged contact with water, you can see by that extract there's likely to be deterioration of the panel, or maybe even possibly structural loss of structural integrity going forward. So that's really just one illustration of what the guidance tries to do, is to not just provide some solutions and integration, but it's the guidance behind it and the reasoning, so that people are able to make informed decisions about material choice and the way things go together. And then just coming towards the end then, I think another really good inclusion are the 3 sets of typical new build constructions that have been drawn to improve the flood resilience of and explain the hazards related to situations where there may not be necessarily a designated flood risk. So this could include surface water flooding, for example, or improving the flood resilience as the result of storm impacts. Now, this is really excellent, and it really underpins that the point that I made earlier about embedding climate change resilience into new build construction. So what that does is as a pair of details that shows, well, this is what you might normally do. These are where the hazards might be and where the mortar might come in, and what the impacts of that internal materials will be. And then these are the simple solutions and mitigation measures that could be taken to help and assist and improve the resilience. And I think they're an excellent set of guidance in there. So my last slide really is a summary. I think this slide is great. Why is it important? I've really focused on that in this talk, but actually we know we are planning on building out lots of new homes. We know how challenging it is to retrofit. We've got to get the building right. And I think this is a really essential reading for anybody who's interested in embedding climate change resilience, flood resilience into building development now, to make sure that what we're building today is appropriate for the future. It doesn't, I know, just as a final point, I wanted to say it's not about promoting building in flood risks, but it does provide guidance on how you can reduce the consequences if you are building in those areas, which inevitably does happen. We have lots, and so that could be, extensions to existing buildings or permitted developments. It's about managing residual risk after all those other measures or approaches have been implemented. But I do urge everybody who's involved with construction to have a look at that. And my last slide is, we think it's so good, we can be writing our own guidance to just dive deep into all the how you use flood, concrete and masonry based on the guidance that's in there, so we can provide some additional assistance with how to do that using those products. So that's me. Thank you very much.
Brilliant. Andy, Elaine, thank you so much. I think you've condensed 20 years of progress on PFI into about 20 minutes. So thank you for that. That's been really helpful. And audience, please do start thinking about some of the questions to ask Andy and Elaine on some of these things. That whole marriage of resistance, recoverability, the products, the process, the systems, these are the people really to start questioning with the knowledge and experience of how things moved on. You've got a great set of speakers to ask some questions. So thank you both for that. I will now pass us on to Joanne, who will give us an overview of aligning PFR in historic buildings. Great
I
stuff.
love how you
Over
say
to you.
they've condensed 20 years of flooding into a 20-minute talk, and I'm about to condense 300 years of construction into one. So that'll be fun.
Good luck.
Yeah, so I'm going to try and condense it into talking about the code of practice. Then I'm going to go on to explain traditional buildings a bit, and then I'm going to talk about how the PFR and 85500 align with it. So if I can go to the next slide. So the code of practice is a great starting point. From a heritage point of view, though, I kind of feel like it has one additional element that it needs to consider. So I gave it a standard 0, which requires you to really understand what's going on with significance. So when you're looking after any projects that you're working on, it's really important that you identify how many listed buildings you might have early on. What are their listing status? Are they in a conservation area? Are they non-listed and in a conservation area? And once you know this, you can do it via the search the list on Historic England. The little thing on the left is actually Plymouth. So that really shows you how many listed assets are in one area. So the reason this is important is basically we've got 3 listings. We have grade 2, grade 2 star, and grade 1. Grade 1's the highest. When you know when you're assessing change, you have to understand the significance. And if you've got a grade 1 building, what you require is more justification. So the higher the listing, the more justification you require. Once you've identified how many buildings you've got, it's really good to then go and talk to your local authority. You might think it's too early. It's never too early. Go and talk to your local authority, explain the project, the timelines you're trying to meet, and then ask them how they want to work with you on this application. It's really important to get early engagement in because we've all got our own time commitments, haven't we? And we've all got high workloads that we're trying to get through. So if you open this dialogue early, then you're going to establish whether you need individual applications or if you could create a design guide, or you could even do a local listed building consent order. Basically, all of these communications and deciding on the process will speed up any work you could do. So my key message on what I think standard 0 should be is listen to one another, learn from one another, and collaborate. Don't expect someone in a conservation officer to understand flooding and a flood person to understand conservation. You know, we're all specialists in our own areas, and that's really important. Go to the next slide. Cool. Yeah, there we go. So standard 3 is fine. I just always think it needs a bit of expansion to include significance in more more evidence. So knowing the significance of the building helps your design options early on. So for example, say we know that the front door is modern of a historic building and it's got no significance, it's less likely that a replacement is going to be rejected. But say we know the door is 300 years old and it's in immaculate condition, you're going to need a lot of justification to actually get someone to consent to you removing it. However, on that note, it's not acceptable for anyone to just say, no, you can't do work because the building is listed or its significance. The thing with conservation is it's about the management of change. And the thing with flooding is you've got liquid moisture problems, you've got the pressure and force from the floodwater, you've got contaminants, and all of these can cause decay, deterioration, and structural impact on the building fabric. And especially when a building is continuously flooded, then you've got the wetting and drying of the materials. So any material, whether it's historic or not, will be impacted by this. So it's about making us understand, you know, what is the flood risk and what is the best solution for the building, taking in its significance. If you go to the next slide. Why is it so complex? I get this all the time. Heritage and older buildings often branded as being complex and complicated and annoying. The thing is, you talk to me or anyone else in heritage, we'd say the same about modern buildings. So for example, with traditional buildings, we're talking maybe 2 or 3 layers of construction. So you've got probably your lime plaster, your main substrate of the building, and then in some situations you might have a lime render. You look at your modding equivalent, you could be talking 7 layers. So you could be doing gypsum plaster, air and vapor check layers, insulation, 2 layers of cavity walls, and then sometimes the cement render. So really, which one's more complicated, 3 or 7? That's not to say, you know, that either's better. They're just different. Modern materials, they don't really respond to their environment. That's fine. That's the reason they're built with damp-proof membranes and damp-proof courses, and they don't respond very well to ground movement. So you'll see a bigger shift structurally. Whereas traditional buildings, they are natural materials. They came from our environment. They're normally quite local. The fact they've got open capillaries means they can take in liquid and they can expel it naturally without any intervention from us. They're also very flexible. So if you think about timber frame buildings that have been around for hundreds of years, you'll see them all being crooked and, you know, looking a bit odd. They're quite happy like that. So, you know, it's just understanding the difference. What's the difference between the modern and traditional? And then being really careful about what materials and methods we bring into them. So a kind of simple way of doing it, if it's a modern material, probably not suitable for a traditional building. And if it's a traditional material, it's probably not suitable for a modern. Can we go to the next slide? So this is just my fun fact. Both these buildings are listed. So don't just assume because you've got a newer building on the project that it's not a listed building. If we go to the next slide. So I've tried to be really quick at explaining why modern and traditional buildings are different, but I'm going to go and explain it into a bit more detail about what traditional construction is. So it's important to identify what your construction is that you're dealing with and determining what materials and measures might be appropriate. So with older buildings, you could be dealing with various different construction types. As you can see from the image on the left, there's 4 different types of material going on there and ages of what's going on. But it's also really important to understand what the owners have done to it. So just because your building might be 300 years old doesn't mean it stayed that way. It's highly likely that someone's taken the floor up and replaced it with a concrete floor, or they've put an extension on. And not always are these materials appropriate, and they could be doing damage whether it's flooded or not. So when dealing with an older building, it's the same as if you're dealing with a flood site. You would hire a flood person who knows what they're talking about to come and do a flood risk assessment. Just hire a conservation accredited person. We've got surveyors, structural engineers and architects out there who specialise in these buildings and can offer you support. So when I first wrote these slides, I wrote it and then I went to a conference last week about flooding and landscapes, and I thought, oh, this could be a really good metaphor for explaining traditional buildings. So you can all tell me at the end if I've totally failed with these analogies. Can we go to the next slide? So, yep, the majority of buildings are solid permeable masonry. So this is my analogy for explaining permeability. So tarmac or concrete paving causes water to run off into our landscapes, right? But when they have a crack in them, the water then gets in between, and then it will cause the material to basically break down because it's trapped, and that's where we get potholes. So when we put an impermeable material, so like a cement render, onto a traditional building, the same thing happens. The water gets behind the concrete, and then it will start to deteriorate the permeable material behind it. So this is kind of why I'm trying to explain, like, don't cement render a cement pointer building. It's an issue as soon as moisture gets in there, and you'll start to find that that's when we start to get a failure. So the other way of like explaining it is the building on the left, as you can see, floods a fair bit. About 2 years ago, 2 or 3 years ago, so the landlord, they removed all of the impermeable materials. It had a concrete floor, it was cement rendered, it was gypsum plastered internally. When they had to decant the tenant, it took 6 to 9 months to dry. Like, that's quite extensive. They removed all of that and then they replaced it back with limecrete and a lime floor. And actually it flooded about 3 months later, 6 to 8 weeks, and the tenants were back in. That's like a substantial difference on the drying time. So let's go to the next slide. However, not all traditional buildings are made of permeable masonry. We also have impermeable masonry. It's a smaller percentage. It's generally granite, flint, marble. There's probably a few other stones I've not mentioned. It's generally in the Lake District, Hampshire, Scotland and Wales. So the difference is these materials, they're not permeable, so they can't in their own right take up the liquid. And this is when the mortar is really important. So we've already discussed cement mortar. I've already given you the pothole analogy. In this point, we need the lime mortar to take in and disperse the moisture. So from a flood or rain, and it needs to disperse across a larger surface area. So my analogy here is not perfect, but let's imagine the lime render or lime mortar is a chalk landscape, right? So we accept that chalk landscapes will deal with flooding much better because they are porous and they're more open, so the water just like free drains quicker through it than if it was clay. The lime render is pretty similar. So it's got expansive areas of pore structures, and all of these pores are able to like absorb and tape up water. So this doesn't mean that it then comes through into the building quicker. It means that actually it spreads across the surface until these pores are so saturated, and that's when it comes onto the other side. So this is like, I'm trying to hopefully get across to you guys, it's really important that we understand the moisture movements of building construction. Whereas if you think about like a concrete render, it's got really low permeability. So if you have a concrete render on something that's already quite low permeable, there's nowhere for the moisture to go. So it's just going to come through to the building quicker. Can we go to the next slide? So an even smaller percentage of buildings are timber and earthen structures. So you might know earthen cob, clay lump, clump. There's a few different terms for it depending where you're from. It's really important, not all of these are listed as well. There's quite a few buildings out there that are timber and earth and they're not listed. So the reason I've lumped these two together is because they've got similar characteristics. They tend to both sit on masonry plinths. So as you can see from the picture on the right, it's quite a small plinth. That could be anything from 1 layer to 300 mils to 600 mils. The main importance is that the main strength of the building actually comes from the plinth itself, not necessarily from the earth and the timber. This isn't to say they're bad constructions. They're actually really good constructions, just slightly less so when they're in a flood zone. And the problem of when a flood occurs on earthen or timber structures is that it will cause erosion of the earthen walls. So as you can see, the collapse that happened to a pub, that actually wasn't because of a flood. It's quite hard to get a flood picture of that actually. That was actually caused because water got in from the rainwater goods and basically saturated behind the cement render, blew it. And you can see the structural failure. Another good reason not to use cement render. Apart from the erosion that could happen on the earthen building, with the timber, it goes slightly different. So timber frames aren't fixed to their plinths. So you've got a major force, you could actually move the entire timber frame. If you've got less of a force, you can pop the infill panels out, which are the little bits on either side of the frame. They can pop out. It could crack the timber frame generally, or it could cause it to splinter. And obviously the amount of water that comes into it causes rot. So one of the questions on that is, if we're thinking about a flood door, why would you install it? If it's going to be above the plinth line, the water, you've got a structural issue. So we try not to think of it that way. So if we go to the next slide. So I'm really hoping my analogies are kind of helping to make a bit of sense on this and understanding why modern and water resistant materials aren't good for traditional buildings. This is actually my house. So the picture on the left, that is bitumen and tar. It's actually the room I'm in now. It was an extremely damp and cold wall. And then the picture on the right, it's a cob wall in my living room that was buried out by rats. And that was because they'd used inappropriate materials in those as well. So you can see the structural failure that actually occurred on the cob wall. Since I've repointed it in lime and re-rendered it, the building's much better. It's warmer, it's drier, and we haven't got any structural issues. So it's just really keen to think about how we do this. So if we go to the next slide. So it was quite interesting reviewing the new 85500. If you read it with the mindset of what a modern building is and what a traditional building is, it's quite evident that modern construction has far more materials to consider, and that many of these materials aren't particularly resilient or recoverable. which is very different to traditional buildings. In section 5.1 in the general, it recognises that all buildings and the materials are different. So when it comes to historic or traditional construction, you're not really expected to do anything different than you would be for any other building. And actually the impact from the floodwater in traditional construction is less likely to result in the material changing form after a flood, whereas it would in the modern. The standard really supports the use of appropriate materials and highlights the use of lime mortars, renders and plasters. And it also highlights the need to fully understand moisture movement and drying to include secondary drying of hidden fabric, which is very important for historic buildings as well as modern. It also talks about how lime plaster can slow flood water and speed up the process of drying, which obviously explained earlier in the permeability. It also encourages you to look for independent professional surveyors or engineers, and that we shouldn't be looking at water repellents for traditional buildings because you risk trapping dampness and increasing either frost damage or structural failure. One of the other aspects, and Elaine touched on it slightly, was insulation. Insulation on traditional buildings is a lot more complicated than on modern, and I'm sure most of you have seen in the news about the external wall insulation schemes that haven't resulted in particularly nice environments. We're doing a lot of work in this area on historic England with universities, and it's still an area that we're trying to understand if there are any materials that are appropriate for it. So it's slightly different to the advice you'd give on a modern building if you're looking to improve its energy efficiency. If we go to the next slide. So I can hear you all going, oh my God, Joanne, but what is it we can do? Loads. So you've got the things I've put on the screen, but you've also got things like, as I keep saying over and over again, sorry, it's really boring, I'm probably banging on about it, lime mortars, plasters and renders, really important. But it is also important you make sure the paints are appropriate after, so you use a lime washer or distemper. If you don't, you might as well have just cement rendered your house again. You can still use water resistant materials, but what we say is like for a kitchen, unless your kitchen's listed, but that's very unusual, but it can happen. And source local natural materials. So your buildings will have been constructed from them in the first place, but if you source for local stone, then you've also ended up with a more resilient floor than if you had a cement one. And also something I just always like to point out is don't assume you have to remove historic timber. So older timber is naturally capillary active, whereas MDF, for example, isn't because it's man-made and it's got additives we've added to it. So you go to the next slide. So it's just a final note really that though property flood resilience has a place in the flood sector, it's not always the right option or the only option. In 2022, I undertook a study with the Environmental Design Studio to understand why certain buildings fell out of scope of receiving government financial support. And then we ended up finding that PFR wasn't the only option. So if you go to the next slide. We identified that there was 14 in total different ways of adapting this building in Yalding in Kent. Ideally, obviously, don't demolish a building, but we have to accept with climate change, these things happen and we can't always control what we're going to have to do. We're shortly going to be tendering for the phase 2 of this, which will be looking at coastal erosion. So that will include coastal land loss and increasing sea level rise from flooding. And then if we go to the next slide. Yeah, so sorry, that was super speedy. It's very hard to get 300 years of construction into a talk. We have revised our guidance. So CIWEM, the Environment Agency, RAB consultants and BeFloodReady have been really supportive of us for the last couple of years doing that. And it will, fingers crossed, be out in the next 2 weeks. I'd hope to get it out today, but we got blocked a bit with images. So yeah, either follow CIWEM's newsletter and I'm sure they'll publish it for Historic England, or come and stalk me on LinkedIn and I'm sure I'll publish about it.
Joanne, thank you for that. Really interesting to see how you can deliver PFR in heritage. And I really liked your standard 0 around the need to talk and communication and collaboration. It's whilst it isn't, it's an underlying principle of the code of practice. There's a few in there. One of them is around communication, but and what we're doing within our training is making sure that we've got the right practitioners speaking to the right people at the right time. So yeah, no, that's brilliant. Excellent. Okay, so we're now moving to your questions. Bear with me. While I do that, I don't really want to spend too much time doing an outro, I'd rather just focus on your questions. We've got limited time, but if you've got a phone to hand, you can scan those QR codes. So just bear with me. Right. I'm going to filter these on the most popular questions. So I'm not going to use the chair's prerogative for a chair's question. Okay, so I suppose there's a question here about could you confirm if we are dealing with flood resilience or flood resistance or both? I suppose really that question could be around when is it appropriate to think about flood resistance or recoverability? And I suppose who really wants to start off with that discussion about the blended approach with regards to resistance and recoverability to improve overall resilience?
Shall I start? And then it was just that I think just because I think it is a core question, and it's one of the big differences with regards to this standard is that resilience is now is the description of resistance and recoverable. People are still sometimes using the term resilience to mean the sort of recoverability aspect. So I think that's a really important bit. If people aren't aware of that updated terminology that's been around for a few years now, that is the first thing to recognise. And it is a combination of the two. I think one of the key things that comes through in this guidance is that to be resilient, I mean, resistance is the first barrier, right? But actually, there's always got to be an assumption that some water is going to get in. And so limiting the amount of impact that's going to be able to speed up that recoverability is an important part of the solution. It's not an either or approach. It is a both approach, but you're trying to impact which. And different solutions and different flood conditions are going to be likely to be able to say one is more likely to happen than another, depending on how permeable or how many holes you've got in your structure. Where's the water going to come in? If there is a historic door that can't be replaced and you can't put a barrier up, water's going to get in, isn't it? So I think that answers part of the question. I don't know if anybody else wanted to build on that.
Can I just quickly add? I mentioned that there were two previous iterations of the standard, and for those partly because of what we found from our initial literature survey 20 years ago, but we did get a little bit bound up with stating that you would have resistance to 0.6 of a metre, and beyond that you ought to not try and keep water out. You should assume water gets in and you make it recoverable. We had many discussions over the last 5 years. We've taken out that depth of floodwater, and so as Elaine said, now they go hand in hand together. And when you get into the detailing and you start thinking about damp-proof membranes, etc., you're clearly going to want to have resistant materials below it. And then you can think about how what you're going to do above it. So absolutely, both approaches, are completely intertwined through the new guidance.
Great, thanks, Andy. There's a question here around, and it's from Fola. So as you'd expect, it might be around. It's about groundwater, I suppose. Is really thinking about whether the newest British standard and some of the approaches that Joanne's thinking about, whether it starts considering the impact of groundwater through foundations.
I can answer that if you like.
Yeah, go on, because I think
it does. It's in the drawings. Yeah, it's recognised as one of the hazards that might be there. It talks about needing to understand it, and in some of the mitigations that it says, if you've got that, then these are the solutions. This, it tracks potential routes through of water into property, and one of the routes coming through is water that's coming up from the ground. Now that might have been specific. I mean, that might have been water that's got into from the outside through in contemporary construction. That might be through air bricks or whatever that's gone into a cavity, into the subfloor void, or it might be groundwater. But either way, it recognises that if there's water there, it might be coming up through and having an impact on floor structure or leak or making its way into inside the property as well.
Great, thanks, Elaine. And Joe, what bearing does this have with regards to historic buildings in terms of groundwater intrusion and impacts on foundations?
So groundwater is quite an interesting one. We get it a lot, actually, especially in older Georgian and Victorian basements, because they were built where there was high ground levels. Most older construction doesn't tend to have foundations. So you've got that as a catalyst. But actually how they're constructed, I've never seen groundwater, someone's going to tell me I'm wrong here, I've never seen groundwater cause a structural issue on a building. Groundwater generally is very decontaminant free, so that's a good thing. If you know you're in a water table, it's just fluctuating up and down. So it's more about how you use the space and less about what the space is always made of. So if you know you've got high groundwater, then it's better probably to have it as a inhabitable space, you know, for storage or things like that if it's in your basement. And I think it's more about, we kind of got to that point, we've got to kind of accept that flooding is going to occur in some way, and sometimes it's more about how you use it, and it's just making sure that you have the best like drying principles in place. So if it comes up, you wait for it to recede, you make sure you dry it, you make sure if there's timber there, it's being monitored and stuff like that. It's not about, you can't just say, well, let's exclude it, because if you're excluding it, where's it going? It's going to go somewhere else, isn't it? I don't think when it comes to groundwater, there's much difference between modern or traditional buildings. Not modern, modern and traditional. I don't think there's much difference to our approach on it, unless you're saying you're trying to get a habitable basement, and that's probably when you have the differences.
Great, brilliant. Well, thank you for that question, Fowler, and thanks for the answers. We've got a question here, which it relates to flooding depths, and for however long I've been involved in property flood resilience, the questioning about what can you do with flood depths over 60 centimeters, 600 millimeters has been there. So this question, I'll read it out verbatim, is as part of the testing undertaken to develop the guidance relating flood performance of buildings and subsequent British standard on flood resilient construction, what, if any, testing was done to understand the capability of structures of different constructions to resist flood depths greater than 600 millimeters? So this is also the interplay of when do you start calling in other skills into the question in terms of structural engineers as well. So who wants to deal with that?
Well, I think if I just start and I'll let Elaine come in. So, yeah, so the 600 millimeters flood depth came originally from looking at the flood resilience, property resistance product. You know, that's where it sort of started. And as I've explained, that was in the 2015 version, but we debated it hotly. That has been taken out. So we've absolutely, you know, not tried to stick to a 600 mil standard. I'm afraid I'm not aware of any actual testing, lab testing, where people have looked at high depths on buildings to see if they're going to fail. The 600 mil came from a report published about 30 odd years ago, I think. So I think the view of the drafting committee was that when we were getting higher depths of water, the water would be getting into the building. You know, even with best effort, you were not really going to keep it out, even if it was just the water pressure outside forcing through the ground and coming up, you know, sort of a groundwater effect. So probably not really answer the question there. I mean, Joanne touched on basements, and there's obviously completely separate British standard guidance on basements and tanking, and we haven't reinvented the wheel there. And obviously, if you're in that situation, you need to go to that separate guidance. So I'm not sure I've really answered the question. Maybe someone else can pick
Elaine,
it up.
Elaine,
Yeah,
yeah.
I think it's good that that was taken out, because it was a rule of, it was a very much a rule of thumb. And I think what's correct that's in the guidance is that actually it's all going to depend on the type of construction. So a single skin wall is going to be very different from a 150 foot concrete construction, for example, or a lightweight timber frame. It's certainly one of the things that we're going to be picking up in our guidance, because a lot of what we do in the concrete centre is provide guidance to stakeholders about the use of precast and in-situ concrete and masonry, and we're going to look at specifically providing some rules of thumb with regards to the structural performance of different constructions and how that relates to depth, to try to assist in that. But I think the guidance in the standard is that you need to talk to a structural engineer and get some guidance about what that specific build-up is that you've got and what the likely depths are. Because it's not just about depth; it's actually about the force and the direction of that flood. So it's too much of a simplified rule of thumb to be. You need to look at it on a case by case basis.
Great. Thank you, Elaine. So that brings us to the end of the discussion. And I think the thing around height is also about the ability to access and egress a property as well, in terms of the height of any resistance or barrier that you put in there. So I want to thank our speakers for their keeping to time. It was me that took us over time, so but thank you for your presentations. Also, thank you for your questions. This will be available, this webinar will be available in the next couple of weeks on the CIWEM YouTube channel, and yeah, we hope to see you at a future event in the future. Thank you very much. Cheers, everybody.